We're showing our blueplanet 165, which is a three-phase photovoltaic inverter and a member of our KACO photovoltaic series between 87 and 165 kVA. This is a range of PV inverters with single MPPT based on the silicon carbide MOSFET semiconductor technology. With this technology, we basically offer the world's best efficiency in this power range, and at the same time, we have a superior temperature rating, so basically, our customers can extract more kilowatt hours out of their PV plant and ultimately then make more money in their pocket. A second advantage of this inverter is that you can put it in the PV plant both on a decentral or on the central way. So you can put it close to the modules or you put it close to the transformer or the AC connection. This is an advantage, this flexibility, and we also show here documentation that with the so-called virtual central approach, so where you put the inverters close to the transformer, you can win up to 2% more yield on your PV plant. Now you might ask, why are we still building single MPPT? We have hundreds of thousands of inverters with single MPPT as KACO in the field, both on rooftops, both on ground-mounted installations, and we see really that in most of the cases we can extract more energy, we have more yield with a single MPPT approach compared to a multi-MPPT approach. Yeah? At the same time, we can also improve the reliability of the plant due to the higher availability of this product. Now, how can we be so sure about that? We just conducted a study with the renowned German institute where we are validating the impact of anomalies in the PV generator on the energetic yield of the plant. For instance, if you have a plant with different string lengths, or if you have a plant with, for instance, the tree in the middle, so a so-called near shading impact. And we found out that for all the possible anomalies, the energetic yield you can have in a multi-MPPT versus single MPPT configuration is fairly small, up to 0. To give you an example, for a near shading, if you calculate it over 8,760 hours a year, so over a whole year, the energetic impact, the more energy you bring to the input of the inverter is just 0.05 to 0.3% in extreme cases only. And this impact gets then mitigated by the lower efficiency of a multi-MPPT inverter, since a multi-MPPT inverter per definition has 2 power electronic steps in series, so you have a lower efficiency than with a single MPPT. And that makes us confident in saying that in the majority of the plants, single MPPT is the best solution to have the optimum plant yield. At the same time, we found out that unfortunately the commercially used configuration or simulation tools in the photovoltaic industry don't sufficiently reflect the behavior of a multi-MPPT inverter. If you're curious, we will be publishing a paper on our social media as KACO, probably by next week. So follow us on the social media, check us, and you will find the details very soon online.